All right, so we're going to start with a definition. So in your notes, jot down that probability is the chance that something happens. So these are the problems like what you may have seen in the past would have been something like you're drawing a card from a deck. What is the probability that you draw a queen? Or you flip a coin. What is the probability that you flip heads? So those are the kinds of problems that we're going to be talking about today. What is the chance that something specific happens? All right, so there are three types of probabilities that we're going to do in this section. We're going to start with classical, which is going to be the biggest emphasis that we do. Okay, so we're going to spend almost the entire class period working on classical probability. And then at the end of the class period, or maybe even depending on how it goes, we may even be doing this Friday. We're going to do a real quick example for empirical and then talk just a little bit about subjective. So the type of probability that you're dealing with is based on how you get the probability. All right, so I'm just going to put just a little bit outside of each of these. All right, so classical probability is going to be based on what we call a sample space. All right, so in your notes, jot that down next to classical, that it's based on a sample space. So what we're going to do first off in just a minute is talk about what that is and how we find that sample space. All right, the empirical, and I'm just going to go ahead and fill out all three. The empirical probability is based on actual data. This means that you actually do an experiment, you collect the data, and you're looking at your data and you're calculating a probability. Okay, and then subjective probability, that one is not very mathematical because it is based on an opinion or maybe an educated guess. All right, so we have classical based on a sample space, empirical based on actual data, and subjective based on an opinion.
I have
Sure, go ahead.
what you mean about
Okay, so yeah, that's what we're about to do. We're gonna kind of pull that idea out and work on sample space. So that's a good segue to what we're just about to do. All right, so I'm gonna go ahead and flip to the next slide then. All right, so here's what a sample space is, and then we're going to work on a couple of examples. All right, so a sample space is a list of all possible outcomes. So it is everything that could happen when you do an experiment. And so what you'll find is that some of these are really, really easy to come up with. And we're going to do some easy ones first. Okay, so these will seem almost like common sense, but we just want to get an idea of how to do it. And then we'll do some that are a little more difficult. All right, so our first one says that we roll one die. Okay, so first of all, like dice, that's plural. That means two or more. And if they say die, that means one six-sided cube. All right, so what you want to do is you want to think about when you pick up that one die and you roll it, what could you roll? Right, and so we know that we could roll a 1, we could roll a 2, we could roll a 3, a 4, a 5, or a 6. So those are all the possibilities for what could happen when we roll one die. Usually you're going to see your sample space written in a set of brackets like I did there, and you just want to list out everything that's possible. All right, so what about this one? You answer a true-false question on a test. So what are your options there for your outcomes? What would go in that sample space?
TRF.
Yeah, T or F, perfect. Okay, so we could answer true, we could answer false. Those are my only two choices. Put it in the brackets. We have our sample space. All right, you toss a coin. So like I said, this is probably the one that you guys have worked with in the past in other classes. We know that when we toss a coin, we could toss heads. I'm just going to say H, or T for tails. Okay. And then this one, it's a little more complicated, but still, I wouldn't necessarily think you would have a lot of difficulty coming up with possible outcomes. If you toss a coin twice, anybody want to give me an outcome, something that could happen if you toss a coin twice? I mean, I could get heads the first time and then heads the second time, right? That would be one possibility. What else?
Tails.
Two tails, good.
Tails head. And then heads tails.
Perfect, good. All right, so I'm just going to point out as we're writing this down that these two are considered different, even though they're both one tail, one head. The order is different, so we end up counting those differently. Okay, so we do have 4 outcomes in that one. All right, everybody okay so far? So like I said, those are pretty straightforward. You shouldn't have any real difficulty thinking through those sample spaces. Everybody feel okay with that? Anybody have a question? Okay. All right, so there are other ones like this. Okay, so we're rolling 2 dice. And the problem with this is that I don't really want to list out this sample space because it's really long. All right, so if I'm doing 2 dice, I know that there are 6 outcomes on the first die, right? I can do 1 through 6 on the first die. And then on the second die, there's also 6 outcomes. And so in my sample space, there should be 36 possible things. And so that's too long. Like, I don't want to go in and list out 36 different things. So sometimes it's okay if you just say to yourself, okay, so I know that this sample space has 36 possible outcomes, and that you sort of have in your head what it looks like. And that's why I've got this chart on the right, but we don't actually have to list it out. Okay, so in the chart, just kind of look at it. You have all the different ways you can roll the 2 dice. All right, so let me just point out a couple of things to you here. All right, so look at this one right here. That would mean rolling a 4 on the first die and a 2 on the second one. And I want you to note that this is counted as a separate option. So that would be rolling a 2 the first time and then a 4 the second time. So similar to the coin toss where we said HT and TH are different, 4-2 and 2-4 are different. Okay, and that's true everywhere in this chart except for the doubles. So like if you look right here at this double, 2-2, it's just there once because 2-2 is the same thing as 2-2. You can't flip them around and have something different. Okay, so on that one, we just kind of want to remember 36 possible outcomes, and then we'll get to what we need when we start working problems. All right, so another one that's like that is a deck of cards. Okay, so there are 52 cards in a deck. So there are going to be 52 things in the sample space. Again, this is too much. I don't want to write out 52 different things. So we won't list out that sample space. We'll just keep in mind 52 possible outcomes. Okay, so what I would suggest here is that you grab your phones and take a picture of these cards. Because a lot of times students will tell me, well, I don't really know that much about a deck of cards, or I don't play cards. And a lot of our problems have to do with cards. So it would be good if you had a picture that you could go back and sort of reference if you need to. All right, so take a minute, take a picture of that deck so that you've got it on your phone. And then we'll come back to that picture in just a few minutes when we start working some problems. Okay, so what about something like this? All right, so we're going to go back to the coin toss for just a minute. All right, so what if we toss a coin 3 times? What is the sample space? Okay, so this is one where I can write it out, but it's difficult for me to be sure that I get all the outcomes. Like if I did a coin toss twice, I could definitely list that one. We did that just a minute ago. That's not a problem. But when we move up to 3 coin tosses, sometimes it gets difficult to be sure that we list them all out. So we have this idea of making what's called a tree diagram. And I want to show you that here. We don't do this a lot, but on a problem where it gets complicated and kind of confusing, this is a way that we can list out the outcomes without skipping one by mistake. And like I said, we won't use it much, but when we've got a situation where we're doing something 3 or 4 times, the sample space, the tree diagram makes it a little easier to work with. Okay, so what we're going to do is we are going to, if we're going to toss the coin 3 times, we're going to break this up into like 3 separate things, like tossing the coin the first time, tossing the coin the second time, and tossing the coin the third time. So I'm going to put like 3 sort of columns up here. So I'm going to do toss 1, toss 2, and toss 3. And then I'm going to come down here and I'm going to put a dot, and that dot's going to be like my starting point. All right, so then I'm going to think through it sort of one step at a time. So if I pick up the coin for the first toss and I toss it in the air, I know that that coin can either land on heads or tails. So those are the options for the first toss. And then what I want to do is I want to sort of think through each of these possibilities. So I'm going to start with this one right here. And I'm going to say, okay, so I tossed heads the first time. And then I'm going to pick up the coin again, and I'm going to toss it in the air. And I know that that coin can land on heads again, or it could land on tails. Okay, I'm going to come down here and I'm going to say, okay, different scenario. What if I tossed tails the first time? So then I pick up the coin again, I flip it in the air, I could get heads, or I could get tails again. All right, so that takes care of the second toss. All right, and then I hope you probably can see what I'm going to do, but I'm going to go through and I'm going to say, okay, let's go back to the first one. Let's go back right here. So now I'm saying that I did heads the first time. I did heads the second time. I'm going to pick up the coin and toss again. I could get heads again for the third time, or I could get tails. So what I'm going to do is kind of branch off. I'm just going to sort of follow my pattern there. We'll branch off from each of these with another option for heads or tails. Okay, so now the first time through, sometimes this is a little bit confusing. Does anybody have a question that you want to ask me about setting that up? Okay, so here's what we want to do now. Go ahead.
So how would you find the answer for that?
Okay, so yeah, let's do that. All right, so we got our chart set up. So now what I'm going to do is I am going to, hold on just a second. All right, so what I'm going to do now is I'm going to take a highlighter and I'm going to try to show you what happens. All right, so we're going to follow along the paths. So that's, I could do heads the first time. I could do heads the second time. And I could do heads the third time. All right, so if I do that, then one of my outcomes in my sample space is HHH. All right, and then I'm going to move on and I'm going to do the second option. So I'm going to come here and I'm going to say, okay, so I could do H, I could do H, and I could go down this way for T. And I'm going to write that one down. All right, so that takes care of, we'll check them off as I go. That takes care of this one and this one. All right, so now what's next? Does anybody know the next one?
Be telltale head.
Okay, but we're gonna try to stay. Let's try to stay up here at the top.
I mean
So
HT.
go, yes, H T H. All right, and that's gonna take care of that one. All right, what's next?
THH.
Almost. Can we get? We've got one more to go on the top part.
HTT.
HTT, right? So that takes care of that one. And then we're going to move down into the second part. All right, so somebody want to call those out to me? So we'll start with THH, right?
Mm-hmm.
Okay, what else?
TTT.
Okay, so THH is here. All right, what about this next one?
T T
THT. Okay, takes care of that one. All right, moving down to the last part. What do we have there?
TTH.
TTH. Okay, and then finally what?
TTT.
Good, thank you. All right, anybody have a question with that? So again, that gives us a way to do a sample space for something that is maybe a little bit more involved, and it might be a little bit harder for us to think through. All right, anybody have a question? Okay, so now we've got an idea on sample space. So let's move on and talk a little bit about probability. Okay, this is where we were heading with this. So this is our classical probability. We have one formula that we're going to use pretty much throughout this entire section. All right, so take a minute and jot that formula down in your notes. Okay, the probability of an event is equal to the number of favorable outcomes over the number of possible outcomes. Okay, so I'm going to go ahead and we're going to start looking at just some examples with this probability using this formula. So we're going to start again pretty easy and kind of move from there. All right, so let's start with a situation where we toss a coin twice. All right, so I took our sample space from the other page, typed it over here so that we can look at it while we do it. All right, so our formula says that we want on the top that we want the number of favorable outcomes. All right, so our first example says find the probability that we get exactly one tail. So what you want to do is you want to go to your sample space and you want to count the number that have exactly one tail. All right, so that would be this one and this one. Now, it doesn't mean it doesn't have anything else. Sometimes when students see exactly one tail, they tell me, oh, there's none of them that have exactly one tail because they all have a head in addition. That's not what it's saying. It's saying that the number of tails is exactly one. So those two options are the only two that have exactly one tail. So I'm going to put a 2 on the top of my fraction. And then on the bottom, that's the number of possible outcomes. So that's how many things all together in your sample space. So I have 1, 2, 3, 4. So I have 2 things that meet the criteria that they're asking about. I have 4 all together. And then I'm going to reduce these fractions. So your calculator should reduce a fraction for you. And that is something we may need to look at when you guys come back to class and we're sitting with the calculator. But for now, most of these are going to be pretty easy to reduce. So I'm just going to reduce them by hand, but your calculator ought to do it for you. We might just need to look at how to do it. All right, so 2 over 4, I know that they both are divisible by 2. So I can divide the top and the bottom by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And then I've got my answer. All right, so I have a 1/2 probability that I get exactly 1 tail. All right, so now let's look at the second one. The second one says we want the probability that we get exactly 2 tails. So how many options in my set have exactly 2 tails? I would just, just one. So one's going to go on the top. And then remember, on the bottom, you put the number of things in the sample space. So counting 1, 2, 3, 4, 4 goes on the bottom. And that one is already reduced. And we're done. Okay, everybody okay with that? Okay, again, try to start kind of easy just so we can get a feel for what we need to do. All right, so here's the one with the 3 coins. All right, and again, I've written the sample space to the left so that we can see it. All right, so I want you to take a minute and see what you think on these two. Okay, so exactly 1 head and then exactly 2 heads. All right, see if you can calculate your probability for both of those. All right, so what did you say for the first one? Exactly 1 head. Anybody got a guess? What'd you get?
2 over 8. I didn't see that other one.
What about that one?
Oh, I didn't see that one either. Okay.
Okay, so what are you going to say now?
3 over 8.
3 over 8, great. Okay, so yeah, exactly 1 head. You're looking for anything that has 1 H in it. All right, so there are 3 in there that are like that, and there are 8 altogether. Okay. All right, and then for the second one, we want exactly 2 heads. All right, so how did you say for that one? Exactly 2 heads. So we would have that one.
3 over 8.
Yeah, 3 over 8 there too, right? And that one. Okay, anybody have a question with those? Okay, all right, good. So let's move on. Let's do something else. All right, so let's think about some dice problems. Okay, so you're going to see a lot of dice problems. We're going to roll 2 dice. So remember that that's our 36 possible outcomes. We talked about that just a minute ago with the 2 dice. This was a sample space that we weren't going to list out because we said it was too big, that we were just going to kind of think about it as we go. All right, so our first problem, we want a sum greater than 9. Okay, so this is talking about on the 2 dice, you roll a sum greater than 9. So a sum greater than 9 would mean that I rolled a sum of 10 or a sum of 11 or a sum of 12, right? And I can't go with the 2 dice. You can't do anything bigger than 12. Okay, so what I want to do is I want to think about how I can do that. Okay, so I want to come up with all the different ways that I can roll a 10, an 11, or a 12, and then I'm going to count them. So on the 10, I could roll a 4 and then a 6. And remember that we talked about how you can turn the numbers around and it counts as a separate outcome. So 6 and 4 also. I could also roll a 5 and a 5. And we talked about how the doubles don't get turned around because a 5 and a 5 and a 5 and a 5 is the same. All right, so what about an 11? How can I roll an 11? What do I do? I could do a 5 and a 6, right? And then a 6 and a 5. That makes 11 too. And that's the only way to do that. And then the 12, the only way I could roll a 12 is by doing double 6s. All right, so now when I do my probability, I'm going to count the options that I wrote down. Okay, so I'm just going to count here. 1, 2, 3, 4, 5, 6. So there are 6 ways to do it. And then on the bottom, remember, you're going to put all the possible outcomes. So we've already said that this has 36 possible outcomes. So the 36 is going to go on the bottom. Right, and then I'm going to reduce. So I'm going to divide top and bottom, if I'm doing this by hand, 6. So 6 divided by 6 is 1. 36 divided by 6 is 6. All right, so my probability would be 1 over 6. All right, so I want you guys to try the next one, okay? Sum of 4, 8, or 12. So I want you to think about ways that you can roll a 4 with the 2 dice, the ways that you can roll an 8 with the 2 dice, and then roll 12. All right, and I'm going to give you a minute and let you see what you can come up with for your probability on this one. All right, so how can I make a 4? Somebody call those out to me.
2, 2.
2 and 2. Okay, what else? Is there another way to make a 4?
No, man. Well, I only got 2 and 2.
All right, what about if I rolled a 1 and a 3?
Oh, yeah.
And then a 3 and a 1. Okay, what about an 8?
Question.
Yeah, go ahead.
We just do any number that can be added into 8.
So, I mean, you're limited. You can't go above 6 because that's what the dice have, but yes. All right, so give me the ways to make 8, somebody. What we got there?
2 and 6.
2 and 6, and I'm gonna go ahead and flip that around and make it 6 and 2. Okay,
4 and 4.
4 and 4,
3 and 5.
good, 3 and 5, and then 5 and 3, right? All right, and then 12, we said the only way to do that was 6 and 6. Okay, so you do have to be careful that you get them all listed. So you really need to think through, make sure you're listing everything, you're not skipping anything. All right, and then we're ready to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 ways to do what they're asking for. Remember, with the 2 dice, you're out of 36. All right, so I can either reduce on my calculator or I can divide top and bottom by 9. So 9 divided by 9 is 1. 36 divided by 9 is 4. Okay. All right,
A quick-
anybody have a question? Yeah, go ahead.
Okay, for the sum of 8, would it been wrong if we would have did 1 and 7?
It would, because if you think about the dice, you know, you don't have a 7 on a die.
Oh, okay.
Okay,
Okay, so the dice stop at what number?
at 6.
Okay, so dice stop at 6. Okay.
All right, anybody else with a question there? All right. Okay, so let's look at some card problems. All right, you're also going to have a good many card problems in the homework, so we need to be able to do that. So pull out your picture that you took just a few minutes ago on your phone. Look at that while we go through these. All right, and that'll help us a little bit as we work on this. All right, remember that in a deck of cards, there's 52 possible outcomes. So that's going to always be the number on the bottom when we're doing our fraction. All right, so the first one says that we want the probability that we draw a heart. So I'm going to go ahead and put the 52 on the bottom because I know that it's going to be there. Okay, so look at your picture and count for me how many hearts there were in the deck. All right, so how many hearts do you have in that picture that you took? Does everybody see 13? Okay, so 13 hearts in the deck out of 52. And now I'm going to reduce. All right, so again, the calculator is going to be my best option here to reduce, but if we don't have it or we don't know how to do it yet, I can divide top and bottom by 13. Okay, so 13 divided by 13 is 1. 52 divided by 13 is 4. Okay, so that's the first one. The probability of getting a heart is 1 out of 4. Okay, what about the probability of drawing a red card? All right, so again, I know that the bottom part's going to be 52. All right, so now I need to look at my picture of the cards and I need to count the red cards. All right, so you guys do a quick look at that. How many cards are red?
26.
26, right? Okay, so again, you can reduce that either on your calculator or by dividing top and bottom by 26. All right, 26 out of 52 should be 1/2. Okay. All right, what about the probability of drawing a queen? All right, so again, out of 52, how many queens are in your picture?
4.
4, good. All right, so we're going to do 4 out of 52. Again, divide top and bottom by 4 or do it on your calculator and you should get 1 out of 13. Okay, is everybody okay so far?
How do you get 4?
How do we get 4 queens?
Yes, ma'am. Well, I went back to the picture that you told us to take a picture of, but which ones are the queens?
The ones, I think they have a Q by them. Let me go back. Yeah, so the ones that have the Q here are the queens.
Oh, okay.
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 Okay. All right. Anybody else question on that? Okay. So let's look at this next one. All right. Make a little room here. So hold on. Let me get to where I need to be. Okay. So heart or a queen. Okay. So the problem gets a little more difficult if you have this word or in between, or if you have the word and in between. So like the first 3, heart, red card, queen, those are fairly straightforward because you're only looking at one thing. But on the second one, heart or a queen, we have to consider 2 things. Okay, so I know that the probability of a heart is 13 out of 52 because we already did that one, right? Right up here. So I know that there are 13 hearts in the deck. And then for the queens, there are 4 queens out of 52. And again, we've already talked about that part. Okay. Somewhere in your notes, I want you to make yourself a note that the or means to put together. Okay, sometimes I will say merge. So essentially what you want to do is take those 13 hearts and those 4 queens and basically put them together in the same set. All right, but I want to go back to my cards for just a second and I want to show you something. Okay, so I'm going to scroll back for just a minute till I get to the cards. All right, we're going to look at hearts or queens. Okay, so here are my 13 hearts. And here are my 4 queens. Right, and we said to merge together. So the slide, I had 13 out of 52 for the hearts. I had 4 out of 52 for the queens, and I said put them together, which essentially means add them. All right, 13 and 4 makes 17. All right, can you tell me why 17 is not quite the right number for the top part of that fraction? Does anybody see anything wrong with that?
Because you added the queen 2 times.
Yes, because this card right here got added twice. Okay, so or does mean to merge them together, but you can't count the same thing twice. All right, does everybody see that? So it's not 17 out of 52, but it's 16 out of 52 for that one. Okay, does that make sense to everybody? Anybody need to ask a question there? Okay, so I'm going to go back. Let's put that in on our screen here. All right, so 16 out of 52 will be our answer. I'm just going to kind of write exactly what we just wrote on the other slide. We can't have 17, but we're going to have 16 out of 52. We're going to divide both of these, I think, by 4 to reduce. 16 divided by 4 is 4. 52 divided, or 52 divided by 4 is 13. All right. right, so that's my final answer on that one. Okay, I'm going to show you one more real quick and then we'll stop there. So what if the problem had said heart and queen? Okay, so and is the other word that makes it a little bit more difficult to come up with. All right, so the and means that you have to meet both conditions. All right, so in your notes somewhere, write down that and means both. So how many cards are hearts and queens at the same time? So I'm going to go back to my picture just for a second. Okay, how many cards are hearts and queens? The only card that is both is that card right there. So there's just one card that has a heart and a queen on it at the same time. So I'm going to come back over here and I'm going to say that my answer is going to be one card out of all 52. All right. Anybody have a question?